Okay, a second way to graph a function is to use the intercepts. Now remember, if you need to go back to our picture of our key elements of a graph, remember that a graph actually crosses the y-axis at some point and the x-axis at some point. We call this the y-intercept. We call this the x-intercept. And notice that we have that on all of our different graphs. Here, our graph is crossing at the x-intercept at 8, 0, and it is crossing the y-intercept is 0, 6. So we're going to look for these 2 points so that we can graph our function. So to do that, here is my function or my equation. Notice it doesn't look the same. Notice that y is not isolated on one side. So sometimes using intercepts is really good for equations that are not in slope-intercept form. Now, to use intercepts, we are going to want to find the y-intercept, and we're going to look for the x-intercept. So here's how we do that. If I want to find the y-intercept, I'm going to plug 0 in for x. Notice it's the other variable. Since I want to know the y, I'm going to plug in 0 for x. So let's go ahead and do that. I'm going to write my equation. And remember, I want to plug in 0 for x. So I'm going to turn this x into a 0. So now I have y plus 3 equals 4 times 0. Well, anything times 0 is 0. So now I have y plus 3 equals 0. I know that looks kind of funny, but it's okay. You can totally have a 0 on one side of your equation. Now, in order to find out what y is, we do have to isolate it. And right now it has a positive 3. To isolate it, I need to move this positive 3. I actually need to turn this into a 0. The best way to turn that into a 0 is to take its opposite. So I'm going to subtract 3. And whatever I do to one side, I do to the other. So now I have, that becomes a 0. I have y. And if I have 0 and I take away 3, I end up with a negative 3. Now, since y is negative 3, my y-intercept is 0, negative 3. Because remember my x, I said it was 0 up here. And when I solved, I got y is negative 3. So I'm going to use this point to help me graph. Now, before we do that, let's go ahead and find our x-intercept. Now, we're going to do the same thing for our x-intercept. So notice I'm going to write my equation, y plus 3 equals 4x. I am going to this time plug in 0 for y because I'm looking for my x. So I'm going to take my y and make it a 0. 0 plus 3 equals 4x. Now, 0 plus 3 is 3 equals 4x. Now again, I need to find out what x is, so I am going to have to undo what's going on here. This is 4 times x. So to undo the multiplication, I need to divide by 4. And whatever I do to one side, I have to do to the other. So now I have 4 divided by 4, which becomes a 1. So now I have x by itself. Technically, it's a 1x, but as a mathematician, I just write it as an x. Over here is 3/4. I actually just leave it as a fraction. We like fractions when we're graphing. So I know this looks strange, and I'm actually purposely doing that because I want you to notice that it's okay to have a fraction as part of your x-intercept. So let's go ahead and take a look now. What is my x-intercept? Now remember, my x is now 3/4. And my y is 0. Remember, we plugged in 0. So how do we graph this? You can graph functions. Or sorry, fractions. There we go. Okay, so let's go ahead and put this as our x-intercept. Or sorry, our y-intercept. Okay, so let's go ahead and graph this. We've got a 0 and then a negative 3. So x, I go to 0. And then on the y, I go to negative 3. So here's my first point. Now, my other point here tells me that I have to go to 3/4 on the x. Now 3/4, remember, is not even 1. So I actually have to come right here. That's 3/4. Can you see? 3/4. And I go to 0 on the y, which means I actually stay right there. So I have a point right here. Now I'm going to go ahead and take my ruler. Since I have 2 points, I can join them to make a line. Make sure you go all the way through your graph. And we have graphed our equation. Here is my y-intercept, here is my x-intercept. Okay, we'll move on to the next one.